Okay, so today we are going to cover solving equations, solving inequalities. We're going to talk about plugging in for equations and multiplying expressions. And if we have time, we'll get to slopes and the slope-intercept formula. But let us start. Okay, so to solve an equation with one variable, usually you end up with something like x minus 8 equals 10, or something along that line. Solving the equation simply means getting the variable, the letter, by itself. And there are different types. So we're going to look at a bunch of different cases, okay? So the goal is to get the variable on one side and everything else on the other side. And everything else is the numbers, right? So in this case, we want to use the x by itself. And what we have to do is we have to look at what is connected to the x, all right? So here we have x minus 8 equals 10, all right? Now we know that the opposite of subtraction is addition. So we know that if we add a minus 8, then we add a plus 8, they would cancel out and give us 0, okay? Which is what we want. We want to cancel this out so that it isn't here anymore.
So you would be adding it?
Yes. So we have to add 8 here. All right. But the thing is, whenever you have an equal sign, whatever you do to one side, you have to also do to the other side. So if I add 8 over here, I have to add 8 over here.
So you forget about the 8.
Yeah, so we know that this 8 is going to cancel out because we already showed that minus 8 plus 8 equals 0. So this is actually going to give us x plus 0, or we can just write that as x, okay? But here, 10 plus 8 will give us 18, okay? So let's look at another example. Let's say, and we can use any variable, so this time I will use z. Z plus 4 equals 3. Okay? So here, I've got z plus 4, and that's going to be equal to 3. The problem is we need to get rid of this 4. Well, we know that if we have a positive 4, we're adding 4, and we subtract 4, we end up with 0. So we need to get rid of this. That means we have to subtract 4. Whenever we do the one side, we do the other side. Now, we have a curious situation here. All right? We have 3 minus 4. Now, when we're subtracting and adding, if you're not sure what to do with positive and negative numbers, we always refer back to the number line. On the number line, we add, we move this way on the number line. When we subtract, we move this way on the number line. Okay? So let us, all right, so if I start here, let's go for 5. So if I start here at 3 and I subtract 4, 1, 2, 3, 4, I end up here at negative 1. Okay, so if you don't remember how to subtract a positive and a negative, just remember subtraction goes this way. You start and then move in the other direction. Okay, so here we'll end up with, these will cancel out, z equals negative 1. Okay, so that's how we get a variable by itself in this situation. Okay, now let us check to make sure that this makes sense. And the way we check is we can simply plug this in for x. Since we said x is equal to 18, that means if we go back to the original problem, I can put an 18 here. So we end up with 18 minus 8 is equal to 10. 18 minus 8 equals 10. That's equal to 10. All right? Does 18 minus 8 equal 10? Yes, 10 equals 10, so that means my answer is correct. We can come back here, and let's plug in there. We have negative 1 plus 4 equals 3. Is that true? If we go back to our number line, we're here at negative 1, and I take 4, if I go 4 to the right, 1, 2, 3, 4. I end up with 3. So 3 is equal to 3. Okay. So when you're solving an equation, once you get your answer, if you're not sure, just plug in your answer back into the original equation, and you can check to see if it's true. If your answer is not true, then you've made an error somewhere, and you just redo the problem. So when you're working on any type of problem, if you don't get the right answer, don't try to figure out what you did wrong. The best thing to do is redo the problem on a different sheet of paper without looking at what you did here. Because we as human beings have a tendency, because our brains are so complicated, your brain knows what you mean, even if it's not true. What you read. So I'll give you an example. Let's see. Out. Assuming that you can read my handwriting, what does it say? Anyway.
Outside is the nicest car I've seen.
Yes, everybody see that? Yes? Does anybody see my error? What's the error?
I don't know, the nice car is everywhere.
I wrote the twice. Your brain fixed that. Your brain automatically repairs things. Your brain fixed that. Even though I did it wrong, your brain said, well, I know what he's talking about, so you ignored it. Which is why when you make an error when you're doing your computations, you can't fix it by looking at it again because your brain knows what you meant. So it will fix it for you. But unfortunately, when you hand in your paper, your brain didn't fix the paper, right? So I get the paper and I go, oh, I was wrong. But your brain fixes things.
I didn't see that.
Oh, nobody does, because your brain, you knew what I meant, so your brain fixed it. And so that's what happens when you're working on a math problem. If you get all the way here, you go, it's not right. Don't try to fix it because your brain can't find the mistake. You have to redo it on a separate paper where your brain doesn't see it, and it will do it right the second time. So you have to remember that. Trying to fix a problem you've already started is really difficult because you can't see the error. Which is why if you've ever seen something, you go, wow, I can't see what's wrong. You give it to somebody else and they point it out right away.
Like
your brain knows what you mean.
It's like an engine room.
Exactly. Exactly. That's exactly what it is.
You don't start it, man, you gotta retake it and build it off.
That's exactly it. All right, so let's look at another case. Let's do 2x equals 20. Okay, here's a little bit different. All right. In this instance, we have 2 times x equals 20. All right. And what we want is we want to get rid of this. Well, we know that the opposite of multiplication is division. So if I divide 2 by 2, I get 1. So any 1 times any numbers or any variable is itself. So 1 times z is z, 1 times y is y, 1 times x is x. So I want to convert this into a 1. And the only way I can do that is by dividing by itself. Okay, so in this instance, we divide by 2. All right? Whatever I do to this side, I must also do to this side. 2 divided by 2 will give me 1x, which is equal to x. 20 divided by 2 is equal to 10. Okay? We can plug back in and check. 2 times 10 is 20. 20 equals 20. Okay? So to get rid of a number that's in front, if it's being multiplied, we simply divide. Okay? Now sometimes they will give you a fraction. All right? So
Well,
let's
get down. So you just cross multiply, what you do up there? I mean,
with a fraction?
Yeah.
I will show you.
No, that one right there.
Oh, this one?
Yeah.
Okay, so 2 divided by 2 is equal to 1. Any number divided by itself. So 4 over 4 is equal to 1.
So
100 over 100 is equal to 1. 10 over 10 is equal to 1. Because 4 over 4 is the same as 4 divided by 4. So I could write this way if I wanted to. Divided by 2. 20 divided by 2, which would give us the same thing, x equals 10. But we tend to write it this way because it's easier to see. Okay? Any questions? All right. So let us go. Sometimes they give you fractions. So let's go with 3/4 y equals 12. Okay? The thing with the fraction is we want to get rid of the entire fraction. And the way we get rid of the fraction is we multiply by its reciprocal. Okay, so let's think about what a reciprocal is. Reciprocal means we flip it upside down. So the reciprocal of 2/3 is 3/2. Reciprocal of 6/7, 7/6. Okay, so if I were to multiply a reciprocal, 2 times 3 would give me 6, 3 times 2 would give me 6. 6/6 we know is equal to 1. All right? So what we want to do is we want to multiply by the reciprocal to get rid of it so that it goes away and we end up with our value by itself. So here, 4/3. And we know that because we have an equation, whatever we do to one side, we have to do the other side. Very true. All right? All right, now, we have a whole number multiplied by a fraction. But every whole number is equal to itself over 1. Doesn't matter what the number is, we can always just put a 1 underneath it. Okay? Because we're dividing by 1, which gives us our number back. So I can turn this into that. And there are two ways in which we can do this. We can either cross cancel or we can multiply across. So let's look at both instances. We're going to multiply across first. Multiplying across will give us 12 times 4. Multiply that. 4 times 2 is 8. 4 times 1 is 4. That'll give us 48/3. Okay? And then we're going to divide that. 48. Because remember, 48/3 is the same as 48 divided by 3. And that is equal to this. Okay? 3 goes into 4 one time. Subtract. Bring down the 8. 3 goes into 18 6 times. So our answer is going to be 16. Y equals 16. So that's one way we can do it, and that works if you don't remember how to cross cancel. In cross canceling, what we do is we do the exact same thing, but we kind of take a shortcut. So we have 12/1 times 4/3, and we look diagonally across. We say, does 3 divide into 12? Well, 3 divides into 12 4 times. 3 divides into itself 1 time. Okay? So this is now transformed to this. 16/1, which equals 16, which we got here. Okay? So when you do cross canceling, and we covered this in a couple of other lessons, which you can go back and watch on our video YouTube channel, we can cross cancel by dividing the diagonal by itself and the one across. It doesn't make a difference to do it this way because 1 goes into 4 times and we get the 4 back. Okay? Now the last example, any questions on this? The last example is,
So this kind of stuff gonna be on this casing,
yes it is.
but it's gonna be multiple choice, right?
Yeah, but it doesn't matter. You just solve the problem and pick the right answer. Okay, so sometimes we'll have something like this. Z/6 equals 13. Okay, we know from the last example that Z/6 is the same thing as Z divided by 6, all right? The opposite of division is multiplication. So if I want to get rid of this, I have to multiply, okay? And whatever I do to one side, I have to do to the other side as well. So if I multiply, I end up, and remember we talked about cross canceling, 6 goes to itself 1 time, goes in this 1 time. We end up with 1Z, or just Z, and that's going to be equal to 13 times 6. 13/6 times 6, 6 times 3 is 18, carry your 178. So our z is going to be equal to 78. Okay? So that's how we solve those. All right? So let us talk about a couple of more examples now that we have this master. Any questions so far? All right? Let's look at this instance. Let's say I have negative y plus 4 equals 6. Okay? This is negative y, but we don't want negative y, we want y. So we're going to have to do something later. But for now, let's at least get the negative y by itself. Well, what do? We're adding 4. The opposite of addition is subtraction. So whatever I do to this side, I have to do to this side. Okay, so I have negative y equals 2, right? But I don't want negative y, I want y. So I need to get rid of that negative number. Well, remember we said that there's an invisible 1 there, right? Because we said that y is the same as 1 times y, right? So that means that this is going to be negative 1 times y. Okay? That makes sense? If y equals 1 times y, the negative y is going to be negative 1 times y. We want to get rid of that negative 1. Well, that negative 1 is being multiplied. So to get rid of it, we have to do the opposite, which is we divide. Okay? And whatever we do to one side, we have to do the other side. All right? We know that any number over itself, positive or negative, they cancel out and give us just 1. That's going to be y. And we're going to end up with 2 divided by negative 1. Now we know from before, and again, you can watch it on YouTube lesson, that a positive times a positive is equal to a positive times a negative equals a negative times a positive equals a negative, and a negative times a negative equals a positive. And the same works for division, okay? So for division, a positive divided by a positive will give us a positive divided by a negative will give us a negative divided by a positive will give us a negative, and a negative divided by a negative will give us a positive. Okay, so here I've got a positive divided by a negative, so that's going to give me a negative. So that would be negative 2. So essentially, I moved the negative from this side to this side. But the way I did it was I had to divide both sides by a negative to get rid of that negative in front. Okay? So let's look at a different, okay, any questions on this? Okay, give me a moment to write that down. Okay, so we can also end up with something like this. Negative 2/3 W is equal to 1/2. Okay. Again, we still have to multiply by the reciprocal. But because this is negative and we want to get rid of it, we're going to multiply by the negative reciprocal. Negative 3/2 times negative 2/3 W equals 1/2. Whatever we do to one side, we have to do the other side, times negative 3/2. Okay? We know that a negative times a negative gives us a positive, so now that's positive. We also know that when we multiply by the reciprocal, they cancel each other out, so we're left with just 1W or just W. Here, we know that a positive times a negative will give us a negative, so that's already handled. And now we've got 1 times 3 over 2 times 2, okay? 1 times 3 is equal to 1, and then 2 times 2 will give us 4. Okay? So that's how we deal with that. All right, any questions? So these are one-step problems because we only have to do one step. Now there are times when we have to do more than one step. So let's look at an example of that. Let's say I have something like this. 3x plus 4 equals 10. We still want to get the variable by itself. All right? But now we have to do two things. We have to get rid of the 4 and we have to get rid of the 3. In this instance, we get rid of the one connected by addition and subtraction first before we get to the one connected by multiplication and division. It doesn't really matter which order you do, but if you do this one first, it's a lot more work. You end up with way more fractions. So we choose, and again, it doesn't matter, we can get rid of the 3 first, but it just makes it a little bit more difficult. So here, we're going to get rid of the addition first. Either way would work, but we always choose in math, do the way that makes our lives easier because we're taking tests. Now the case is untimed, so it doesn't matter. But later on, if you're taking the SAT or the GRE or the admissions for college or the A+ certification or the ACE, which one's the mechanical one? The one that mechanics get certified for?
Oh, mechanics?
Yeah, there's some sort of certification. But anyway, it doesn't matter. Whatever you're doing, it's a timed test. So you want to always do what makes life easy for you. Okay? Either way would work. So if I want to get rid of this 4, because I'm adding it, I need to then subtract it here. But this is an equation, so whatever I do to one side, I have to do the other side. Okay? And we always do one step at a time. So now this one is canceled. We end up with 3x equals 10 minus 4 will give us 6. Okay? Now we do step 2. We have to get rid of this 3. And again, this 3 is connected to this x by multiplication. So we disconnect it by division. Okay? Because remember, 3 divided by 3 is the same as this. And that's going to be equal to what? X. Whatever you do to one side, we have to do the other side. So x is equal to 2. So those are our 2 steps. It works with fractions as well. Okay, I'll let you copy that down. Well, draw it down. It works as fractions as well. All right, so we'll make this one a little bit more fun. Let's say I had 7 over 8 y minus, so we have negative 7 over 8y minus, oh, I don't know, 3 equals 6. I don't know, just goes. All right, again, we have to, can I love math? Math is fun, I love math.
I hate
I wake up
this.
there. You can't say hate. See, here's the thing.
I hate math.
Think about all the things you're good at. You're only good at things you like, right?
Mm-hmm.
So if you hate math, you're telling yourself, I can't be good at it. So you have to change your mind and say, I love math, and then you'll be good at it.
I tried that, but it didn't work out.
You gotta do it. Every morning you wake up, the first thing, get out of bed, say your prayers, first thing you say is, I love math. When first person you see in the morning, say, hey, did you know that I love math?
But then I'll be lying to myself,
Yeah,
and I
but-
don't like lying to myself.
But if you say it every day for the next 30 days, you will actually love math.
You think
I
I'll try
guarantee
it.
you.
I'll try it.
Actually, it takes 21 days to form or break a habit. If you do it for 21 days straight, you're going to wake up and you won't even remember thinking that. You'll just go, God, I just love me some math.
I don't.
I just love math. I've been thinking about it all day long. And I love math. Math makes me happy. It makes me smile.
I mean, I like beer, football, and some wings and cars.
Some wings and cords.
I love me that.
Math makes me smile. Because there's always an answer. All right. Okay, so again, we want to get rid of this. We could get rid of this first, but it would just make life more complex. So what we're going to do is we're going to add 3 here because it's connected by subtraction. These we know are going to cancel. Whatever we do to this side, we have to do this side. Okay? Okay? Now we have to get rid of this negative 7/8. And again, we multiply by the negative reciprocal. Whatever we do to one side, we do to the other side. We know that these will cancel. We'll end up with y here. Okay? We know that 9 is the same as 9 over 1. So we're going to go ahead and just write that out. 9 over 1 times negative 8 over 7. Okay? There's nothing to cross cancel because 7 and 9 don't go into each other. So we just have to go straight across. 9 times 8 will give us 72. We know this is negative because we have a negative times a positive. 72 over 7. You can either leave it like this as an improper fraction, or you can turn it into a mixed number. If you turn it into a mixed number, we can ignore the negative for now because we already know it's negative. And then we'll just do this. We'll do another color so it shows up. Is this green? Dry? Here we go. So we'll just do this in another color. 72, 7. 7 goes into 72 one time. Bring down the 2. 7 goes into 2 0 times. And our remainder will be 2 over 7. Because it was negative to begin with, it turned out that way. Either way would be right. Sometimes on the Casey or any of your other exams, they'll put it as an improper fraction. Sometimes they'll put it as a mixed number. So those are our 2 steps. Then I'm going to show you a different way of looking at it, just so you understand why I love math. Oh, you may not understand, but sometimes they will say, they'll give you something like this. 14 equals 8 minus x. And you say to yourself, oh my God, the x is on the wrong side. What will I do? What shall I do? Doesn't matter. There's this thing called the commutative property. And what the commutative property says is that it doesn't matter which order it is. So if we have A equals B, then B equals A. It doesn't matter which side it's on. Okay? It doesn't matter. So we can leave the x on this side as long as we get it by itself. Okay? Or we can move the x to the other side. I usually like to leave the x where it is just because it makes life easier, but you can just as easily move the x to the other side. So we'll do it both ways. Okay? So let's first move the x to the other side. All right? So to move the x to the other side, it's like moving anything else. It's being subtracted. So to move it, I would do the opposite, which would be to add it. So I know with 14 plus x equals 8. Then I would subtract the 14, move it to this side, and I end up with x equals, if I start out here, or way over here at 8, and I subtract 14, we know that it's 8 steps from here to here, and then we need 6 more steps, which would give us negative 6. That would give us negative 6. Okay, so that's one way to do it. But the way that you could also do it, because some people get so attached to the x being on the left that they do all that. But we don't have to have it. We do want the x by itself. We don't care. We want the x by itself. So here, this 8, the x is being subtracted, but this 8 is actually positive, right? Because there's no negative in front, right? So we're essentially adding this 8. If there's no negative in front, we're essentially adding it. So to do the opposite, we must subtract, all right? That makes sense because there's an invisible plus here because 8 is positive. Whatever we do to one side, we have to do to the other side. Okay? All right? But I don't want negative x, I want x. So what did we do last time? We divided by negative 1. Whatever we did to one side, we did to the other side. This gives us an x because a negative divided by a negative is a positive, and a positive divided by a negative is a negative. Okay? Which is the same as this. So it doesn't matter what side the variable is, what the side it's on. We just want to get it by itself. And that's solving the equation. Any questions on solving the equations? Okay. So, what what we're going to do now is we're going to use that same concept with inequalities. Now, most people are afraid of inequalities. And there are all these little tricks and rules that we learn about inequalities. But in inequality, we have essentially 4 basic types. And if we're reading from left to right, this is greater than, less than, greater than equal to, or less than equal to. But it really doesn't matter. We just have to remember that the larger side faces the larger number. Okay? So you don't have to try to remember which way is less, which way is greater. Just remember the larger side faces the larger number. And again, we always want to get the variable by itself. There's one difference when we're solving inequalities. So let me show you. Let us say, well, let's do one. X. Let's say x minus 4 is greater than 3. We solve the inequality the exact same way we solve an equation. Since we're subtracting, we have to do the opposite. We add, and then we add. So x will be greater than 7. Okay? We do it the exact same way. There's one time where we have to do something different, and I'll show you in a bit. Okay? The same thing here. We did it the other way. If we had 11 greater than y minus 4. Again, we do the exact same thing. We want to get the variable by itself. So because we're subtracting 4 here, we added here, we added here, and we end up with this. Now I can turn that around, but if I'm going to turn it around, I'm not swapping these two. I'm essentially picking this up and flipping it the other way. So y, the small n still faces y. Right? See, the small n is facing y on this side. If I wanted to flip it the other way, the small n still faces y. All right? So we don't flip it like this. We don't flip that. We don't do it that way. If we're going to flip it, we need to keep it oriented the same way, which means the larger side is facing 15, so the larger side is facing 15. So if we want to flip it to make it comfortable, or if they give you the answer in a different form, you just have to remember that if you have an inequality, whatever side is facing the variable, it stays facing the variable if you move it to the other side. That make sense? So if I had z, which was greater than 4, okay, I still have to have that. I have to have the open side facing the z. So the orientation stays the same. Okay? Any questions on that? All right, so let us look at the other case. Let's say I have 3z is less than 15. Again, I do it the exact same way. I need to get the z by itself. It's connected by multiplication. I do the opposite, divide, because remember, 3 divided by 3 is the same as 3 divided by 3, which is equal to 1. So we end up with z. Whatever I do to this side, I have to do this side. And that will be equal to 5. So z is less than 5. Okay? Now, here's the instance where it's different. Let's say I have a number line. Okay? I have 0, 1, 2, 3, 4, negative 1, 2, negative 2, negative 4. Okay. So, in this instance, 3 is larger than 2, right? 3 is larger. Larger numbers are on this side, okay? But in this instance, because negative 2 is on the right, negative 2 is larger than negative 3. You with me? So, we just saw that we can multiply both sides. So here, if I do times this, if I multiply this side times negative 1, whenever I do this side, I have to do this side, right? This would be -1 times 3 will give us -3, -2. Well, this can't stay this way, right? This one can't stay. We can't write that because we know the -3 is smaller, right? So whenever you multiply by a negative number, or whenever you divide by a negative number, and you have an inequality, you have to flip the inequality the other direction. Okay? So because -2 is actually larger than -3, we have to flip it if we ever, whenever we multiply by a negative number. You always have to flip it. Okay? So let's look at some examples. If I had -2y is greater than or equal to 4, again, I would divide by -2. Whenever I do one side, I have to do the other side. Okay? Y, we have to now flip this the other direction. -2. We have to flip it the other direction. If we multiply or divide by a negative, the inequality has to flip the other direction. Okay? And that's because of the way the number line is set up. Okay? On the positive side of the number line, the larger the number, the greater the value. On the negative side, it's the opposite. The larger the number, the smaller the value. Okay? That's because the number line increases this way. So because of that, whenever you multiply or divide by a negative number, you're actually reversing the roles, which is why you have to flip it. Everybody with me on that? Okay, so let's do a two-step one. So we'll do a two-step one. So let's say, let's make it really fun. Let's make it 2/5. I feel like it's a better marker. There we go. So we're gonna make this a real fun one. -2/5 x plus 8 less than or equal to, let's go with 1/3. Only because that looks really fun. That's a great one. See, that's why I love math. It's a great one. See, the problem I have with most math textbooks is they make all the numbers nice and whole and even, but when you get on the test, they don't do that. So you're like, oh my God, it's not an even number. So you keep trying the problem thinking you're supposed to get an even number. Oh, life doesn't work that way. So we're going to do it like this. All right, so do the same thing. We still have to get rid of this 8. So we have to subtract the 8. Subtract the 8. Oh my God, I've got 8. Oh my God, what am I going to do with all this? Well, let's do this. We have 1/3. And we have 8/1. We got to get a common denominator. And we covered this also in our other video. All right, so 1 and 3, they both have a 3 in common. So this is going to be 24/3, and this is going to be 1/3. Okay? 1 minus 24 will give us a negative 23, right? Negative 23/3, right? Because we started here at the 1, we can ignore the denominator. If I start here, if this is 0, if I start here at 1, and I'm subtracting 24, I'm going to subtract here. I've got 23 left to go, and up over here at negative 23. Okay? That's why I like that problem. I like messy problems because they make life so much better. So now we have 2/5 x less than negative 23/3. Notice when we subtract it, we did not flip it. That only happens when you multiply or divide by a negative number. When you subtract, you don't flip it. Okay? Now we have this. We have negative 2/5. X is less than or equal to negative 2/3 over 3. Okay? Again, we're going to multiply by the reciprocal, but because this is negative, we're going to multiply by the negative reciprocal. 5 over 2. Whatever we do to one side, we have to do the other side. Negative 5 over 2. Okay? We know this is going to cancel. The 5 is going to cancel. The negative is going to cancel. So all this is going to cancel. We're going to end up with x. But we just multiplied by a negative number, so we know automatically we got to flip this guy. Automatically. As soon as we multiply or divide by a negative, we flip this guy automatically. He automatically gets flipped. Now we're just left with this. We have negative 23 over 3 times negative 5 over 2. A negative times a negative is a positive. So we know that's going to be gone. So now we just do 23 times 5.
Why don't they just let us calculate it on the test?
Okay, so the GED, they allow you to use calculators, and the KC, they don't. And the reason why they don't want you to use calculators is because they want you to, before you start using calculators and computers, they want you to understand the process first. So the thing with math is, by doing it by hand, you start to recognize patterns, and you start to see how things work. After that, you can use a calculator. So when you are taking algebra, for instance, if you start to recognize patterns, it makes factoring easy. If you use a calculator, it does not, even though they have the fancy schmancy calculators to do everything.
You just gotta get familiar with the numbers.
Exactly. You have to get familiar with the numbers before you can do that, because I was at the post office the other day. I went to go buy some money orders. And the guy plugged the things in, and the number was wrong. And I said, that number's wrong. He said, no, it isn't. The machine says so. And I said, when you multiply by 10, you move the decimal one place over. And he said, oh, the machine is wrong. I said, yes, I'm a math teacher. The machine is wrong. So he said, oh, I must have done something wrong. But because he's so used to pressing buttons, he couldn't see, even though he knew in his mind 10 times, just move the decimal place over. He was like, but the machine said it. So you have to know that so that you can recognize it. I mean, I'm a techie. I love computers, I love calculators and everything. But I would end up paying more if I didn't know math. Right? So that's why you want to know, because you're not going to always whip out your calculator or your phone to check. You know, when you're going to the store, when you're buying something, whether you're buying a car, buying a house, or buying a candy bar, you want to make sure that you're doing it right. And the only way to do that, because we're so lazy, we're not going to take out our calculator and double check. That machine says something, we go, oh, okay, you just write it. But if you know math, you go, okay, that doesn't seem right. And then you'll take out your calculator. That's why.
I guess we all like doing what we like doing.
Yes, absolutely. Okay, so 23 times 5.
No, 213.
5 times 3 is 15. Carry your 1. 2 times 5 times 2 is 10. Carry plus 1 is 11. That'll be 115 over 6. Okay? So that's going to be 115 over 6. And again, it's positive because negative times a negative is a positive. Okay? All right. Any questions on this? All right, the last thing we shall cover today, so that your brains don't explode with all this wonderful math, and then you don't go to your teachers and say, I don't want to work on government, I want to work on math today. So you don't do that. And when you go home today, you're like, I'm not watching TV, I'm doing math today. So instead of doing that, I guess I'll let you go. All right, so sometimes they'll give you, well, I kind of do that. I want to work on math today. Sometimes they'll give you something like this. You know, where you'll say, they'll say 3x plus 7, and x is equal to 2. What does that mean? And essentially, you just plug it in. That'd be 3 times 2 plus 7, which is 6 plus 7 equals 13. So sometimes they'll give you an expression and then tell you to plug in for values. Sometimes they'll give you something like this. You know, 6x plus 4y, when x is equal to 3 and y is equal to 4. And all you do is just substitute. You don't write 63, you write 6 times 3 plus 4 times 4. Okay, 6 times 3 is 18, 4 times 4 is 16, and you end up with 34. So that's the other thing that they'll do. They'll do that. Okay? Any questions on equations, expressions? All right, so I was going to go over slope and everything, but I think I may be overloading you with that, so, and it's almost an hour. Any questions? Alrighty. Thank you for coming. There won't be class on Wednesday because I will not be here, so we will resume on next Monday with the next session. And remember, I love math every day. 21 days to break or make a habit. You can write little affirmations on your board, on your mirror when you brush your teeth. I love math, I love math.
But I really don't.
Yes, but you have to. We're only good at what we love.